Lily Paša-Tolić, and I am laboratory fellow at the Pacific Northwest National Laboratory in Washington, Richland, Washington. I am an expert in mass spectrometry, instrument development and applications, specifically for proteomics and metabolomics. And more recently, I got very much interested in this small sample sizes down to single cells, and so that's an area that I've been actively developing over the past several years. Yeah, so I think nanosplits is the first technology out there that enables us to look at the large number of proteins, say in the range of 2,000, and also a large number of genes from the same single cell. These technologies, or comparative technologies, are primarily based on antibody usage, which is limited in the number of targets one can have. It is actually targeted approach versus discovery non-targeted approach that nanosplits provides, and it also depends on the pretty much depends on the specificity of the antibody, right? So there are certain advantages, and as I said, it's the first more broad, more comprehensive approach for looking at the two different biomolecules from the same single cell. It also provides, unlike these competing or existing technology, it provides access to the intracellular proteins and even nuclear proteins, which are important in terms of cell regulation, including transcriptional factors, for instance, etc. And these are not accessible using comparative or other available technologies. cellenONE has been like a really enabling technology for us, and I think more than that, we have this very close collaboration with our cellenONE partners, which has been very inspiring. We have Josh, who is located very close to us in Spokane, and who is very happy to come over and help us out whenever we need him to be around. So I think it is this more of a multidisciplinary, cross-disciplinary approach that we are trying to take advantage of, where he provides, or cellenONE in general provides, expertise on the cell sorting, small volume manipulation, as well as more of a transcriptomics technologies, while we come from mass spectrometry based world and can provide that expertise in terms of proteomics. So I think it's extremely fruitful collaboration has been so far, and with bright future in my opinion. We are certainly taking advantage of cell sorting. We are. It's great to have this visual confirmation of your sorting event. It enables us to reduce to improve the technical quality, reduce unnecessary runs for the samples that are not necessarily single cells or are multiple cells, which is important because proteomics, as you might know, is still pretty expensive and time consuming. So these things are definitely great. Also the contactless dispensing of small volumes is extremely powerful in terms of not introducing contamination, etc. So these are just some of the things that come to mind. Yeah, so I think we are still very limited in terms of throughput. A majority of the experiments we have done so far have been done using label-free proteomics and transcriptomics approach. So it's really time-consuming and does not allow us to look at the larger number of cells, which I think is necessary if you are in a single-cell business. So I think the next step would be to implement a multiplexing, like barcoding for the transcriptomics and some sort of TMT based multiplexing for the proteomics workflow in order to increase throughput, we hope, an order of magnitude, if not more, and allow analysis of thousands of cells versus hundreds of cells, which is what we can do currently. I think it's still pretty early in the game. We were at the ASMS, which is the American Society for Mass Spectrometry conference earlier in this month, earlier in June, and James Fulcher, who is one of the main contributors to this project, presented on this subject, and there were quite a lots of interest. We also have some work funded by NIH, National Institute of Health, in mapping different organs molecularly at the single cell level, and there has been some interest within these programs to implement technologies such as nanosplits for multiomics. I think the interest will just increase as the time goes by and as we develop these disposable chips jointly and enable more people to do this.